Hello everyone, I am Dr. Rajesh and I am again with you with my next video lecture. And in this video lecture we will learn how to locate the missing term in the given table. Like in this table we are given the various values of y at x, but one term, this term you can see is missing, so we have to locate and try to find that missing term. And the next question is, explain why the result differ from 3 raised to the power 3, which is 27. So I am going to mark, without wasting time, I am going to mark this question as important question from examination point of view. And now look over here, here 5 values are here of x, but of y we are given only 4 values. Fifth we need to determine. So if I say that effectively there are 4 functional values of y. So if 4 function values of y are given, then we know a result that a polynomial of degree 1 less than 4. If 4 values are given, then a polynomial of degree at most 3 can be fit into this given data. So if we say that a polynomial of degree at most 3 can be fit into the given data. If a polynomial, say fx, of degree at most equal to 3 can be fit into this given data, let us suppose that we assume that it has maximum degree 3, then when we apply 4th order forward difference operator upon this polynomial of degree 3, we know up to the same order, that of the degree of the polynomial, the result is constant, but we have applied one higher order forward difference operator, so this will give the result 0. You know this one. So I am going to use this particular result. Since here degree at most can be 3, so we assume that it is 3. So then 4th order forward difference operator will be 0. So in this case we have assumed that fx is a polynomial of degree 3. Fine. So this we will use. So this is f of x. You can also write over here, this is f of x. So it is true for every value of f of x. And if I say this value is x naught, this is x1, this is x2, this is x3, this is x4. Similarly, f of x naught is, say, y naught, f of x1 is y1, y2, y3 and y4. We need to determine y3. So since it will annihilate, 4th order forward difference operator will annihilate every value of the polynomial at any point. So if I say that this will also annihilate the value of the polynomial at point x naught, this implies that delta 4 y naught is equal to 0. So we know that a relation that delta plus 1 is equal to e, this implies that delta is equal to e minus 1, where e is nothing but shift operator. Fine, this is shift operator. Now use over here, what we will get? We will get e minus 1 for y naught is equal to 0. This implies that using the binomial theorem to expand this one, what will get? We'll get c 40 e4, since here is minus, so here will be minus, at alternate position we will be using minus, c1 e3 plus 4 c2 e2 plus 4c1, this is e1, and at alternate position you has to use the minus sign. So here will be minus, so I'm going to use it over here, the minus sign. It will be minus, and next will be plus 4c0, and this will be e0, and outside will be y0 equal to 0. This further implies that 4c0 is 1, e4 minus 4c1 is 4, e3 plus 4c2 is nothing, but it will be 6. It will be 6 e square minus it will be 4 e, and plus it will be 1, and e is 0, it is nothing but 1. And you can, since these are operators, so I will write it as identity operator. So this will be y0. This further implies that now this operand will go inside the operators. e4, because it is distributive over addition, y0 plus 6 e square y0 minus 4 e y0 plus y0. When e4 applied, shift operator applied 4 times upon y1, so once again I am going to show, one time it is applied, it will take it to y1, one more time it is applied, it will take it to y2, one more time it is applied, it will take it to y3, and one more time it is applied, it will take it to y4. So instead of this one we can write as y4, and here we can write it will take it to y3, here you can write y2, and here you can write this will be 4 y1 plus y0 is equal to 0. Now substitute the values. Y4 over here is 81, for y3 is to be determined, 6, y2 is 9, 6.9 minus 4, y1 is 3 plus y0 is 1 equal to 0. This implies that 81 minus 4 y3 plus 54 minus 12 plus 1 equal to 0. This further implies that this will add up to 81 and 54 is 135 and 136 minus 12 minus 4 y3 equal to 0. This implies that this will be 124 and this will go over here, and this will be 124 by 4 is equal to y3. So this implies that this will be 31 is equal to y3. So the missing value we have located is 31. Now the next question is why it differ from 27? Because the values that we have written in the table is with the help of the equation 3 raised to the power x. When we put x 0, it will be 1, 3 raised to power 0 1, when 1 it will be 3, when 2 9, when 3 it will 27, and something like. So this is the value estimation with transcendental equation. This equation of the type a raised to the power x is a transcendental equation. So in this we have approximated the values with the help of transcendental equation, while here the value that we have determined 31 is approximated with the help of the polynomial. So here we have used the polynomial to find the value which comes out to be 31, but here it has used the transcendental equation to find the value. So therefore the result is different. In our case we have used the polynomial to approximate the value at point y3, but in this case, if we will use 3 raised to the power x, transcendental equation will be used to find the value of y3. So therefore both the equations are different, the results given by them will be different, so hence the result differ, because we have approximated the value of y3 with the help of the polynomial, okay, not transcendental equation. So hence the difference you will write in the examination, the same logic. So this question we have estimated the missing term and explain the reason why it is differing from 3 raised to the power 3. And if we are given, let us suppose that 7 functional values, in that case what logic you will use? You will use the logic like we are given 7. So 7 functional values are given, so it can be a polynomial of degree at most 6. So in that case we will be using 7th forward difference operator equal to 0. And if we are given 6 values, functional values, in that case it can be a polynomial of degree at most 5. So that in that case 5th order forward difference would kill the polynomial of degree 5, and rest of the result will remain the same. You will put over here the first value y0 and expand it. You will substitute at place of delta, you will use this one, and you will expand by binomial theorem. So you can, based upon this question on the similar lines, you could solve the other questions very easily. So I hope that in this lecture you will be able to grasp that how to find the missing term and how to explain why the result is differing from 3 raised to the power x or something like 2 raised to the power, whatever the result is asked, question is asked in the given problem. So you can just answer it that because we have approximated with the help of polynomial, so results from the polynomial are different and from the transcendental equations. So that is the reason. So this question is very important from examination point of view, and I hope that I will be able to understand the concept in your minds. So that's all I have from this lecture, and very soon I will be with you with my next video lecture. Till then, take care. Bye bye. See you.